Hello everyone. Welcome again to another video. We have today minimum difference between highest and lowest k scores, right? So basically the question is saying that we have been given a number k, right? And then you take um k many elements in the the list that you've been given, which is nums, and then you find the difference between the highest of those k values and the lowest of those k values, right? And then return for each iteration or for each nums, right? For all those possible keys that you took, return the least difference, basically, right? The question writes itself. The title is very simple to understand, and I think the second question is one of the the easiest one to see, right? Of what the question is asking. So let's say you have 9, 4, 1, 7, right? We want k at most. You take k at most numbers, right? So you have 9, 7, and then find the difference between that. That is 5. Here again, it is what is 8. All right, which is 9 and 1. 9 and 7 is 2. 4 and 1, that is 3. 4 and 7, that is also 3. And then again, what? 1 and 7, that is 6. So you notice also it's an absolute difference, right? So we like if let's say you subtracted 1 from 7, it will give you -6, but we are interested in absolute differences. That's why we have what 6 here, for example. Okay, so how would you approach this question? Well, basically, you could use brute force, right? You have a set, and then you maybe like a tree set, right? Then you come and take k at most k elements with each iteration, and then check for the the minimum difference, basically. But how do we speed this up, right? Because if we did that brute force, it's going to be what uh, with the between the sorting and the looping through, it's going to be like n cube log n, right? So that is not necessarily the best. But how do we like optimize our strategy? Well, basically we could use the sliding window method, right? But the sliding window method, after we've sorted our input, right, which is nums, right? Because if you sort nums, it gives you the elements in a hierarchical order, right? And we'll see that in on the board. But right. So you have everything in a hierarchical order, right? So we have 9, 4, 1, and 7, and then we have this in a hierarchical order. So now with this in a sorted order, right, we can easily find the minimum. We already know the minimum is going to be on the left side, and anyone that is bigger than our minimum is going to be on its right, right? So we know that the minimum possible is what 1, and the maximum possible is 9, right? So obviously minimum possible, not maximum possible, is probably not going to yield what's the minimum difference. We want elements that are as close to 9 as possible, right? So one way we can do it unconsciously is um use our sliding window method, right? So we have this sorted, right, and now we can look at windows with what at most k elements, right? We have two, so k elements. So we take the first element and then subtract it from the second element, right? And that those will be our differences, right? And again here, so we have 1 and 4, right? Initially, and that'll yield a difference of 3. We have 4 and 3. Without this window, that'll yield a difference of 3, and then we have what 7 and 9. This will yield a difference of 2, and this is where eventually we return, right? So once we sort them out and we go in k channels, right, that will be helpful. And we can always know in mind that the elements with the smallest difference are those ones that are closest to our elements. That's why going in these kind of windows is better than like I don't need to check, for example, if I check this window, I don't need to check, for example, what's one's relation to 7 and 9, because I know that this window, right, this window, because it's closer to 1. So at the worst case scenario, right, we'll have elements that are closer to 1 because we have sorted it out, and the elements that are farther away from 1, for example, they are bigger than 1, and hence the difference will be bigger and bigger. So without further ado, let's just get into that. I'm sliding window method. Okay, so here we have our case interesting, right? We have this k is equal to 1, for example, k is equal to 2, and the k is actually saying that we want two elements in our, our block, right? But except we use zero indexing. So if I have two elements, it will be 0 and 1, for example, then the difference between them will be 1 instead of k. So I have to keep that in mind. But basically, we want to have our pointers, right? We want to have a pointer for, let me just make a sequence, all right? So from left to right, and then I want to have our main difference, right? So our main difference will be infinity initially, right? Positive infinity also. Okay. Now with that, I want to loop through, um, you know, nums. So right should be less than nums dot length, right? And then we have a different while loop so that we have an expansion. So that we can have our expansions, but make sure that we have elements, you know, within our window being k minus 1, right? Like, as I previously explained. So I want first that when my right and left is greater, actually right and left plus 1 is greater than k, right? Then I should move my left forward a bit. So if the size of the window, right, which is right minus left, is equal to what, k minus 1, then once we have a window of what size, k minus 1, right, now we can update our main difference, right? So our main difference will be equal to the math dot main of the lowest element, sorry, the highest element in our nums, right? So nums right minus what, nums left, and then itself and main difference. Excuse me. So with that, then we keep increasing our right. Excuse me. And I think right minus left. Okay, cool. Right minus left. I want the size of the window to be, now when it's greater than k, right? So I should take this plus 1 out, right? So when the size of it is greater than k, um, actually k minus 1. If it's greater, then we keep increasing our left, right? So then we return our main difference. That should be it. Okay, output negative. Oh, sorry, and I forgot. But initially, I just assumed we have sorted our, nums, right? But we have to sort it as previously explained. Oh no, I didn't do that there. Right, so we pass the first two test cases, sorted out, and then you get the difference in between them. And I think my internet is down because I previously submitted this solution, and I had come on, guys, I had um 80 something percent, right? So let me see. Uh oh, I see the difference also. I think instead of starting from 0, right, we can have our k start so we can have our right start immediately from what, k minus 1, right? I think that makes it faster, honestly. It's not, it's still bad. One second. Oh no, not this one, not the solution. Wait, what am I doing wrong? Why is it slow? Or it's just my internet, probably. Okay, let me check this one out. It's still the same thing. Come on. uh, I have no idea why it's so slow. But it's definitely how you can approach this problem. It's going to be an n log n solution in the end. Um, I can't really say anything. But for the same solution, I had 89% here. Whether you want to start with the right at 0 or start at k minus 1, it won't really change anything. This is one of the best ways to solve a sliding window method after you sort um, your input. And I hope you guys got good stuff from this video. I'll see you guys on the next one. Peace.